Okay, welcome back. We're going to look at our first three examples here for using sine, cosine, and tangent. Now sine, cosine, and tangent are functions. And functions are a little bit different. They're not like multiplication or division or anything like that. Remember, functions are like actions on a number. So sine, cosine, and tangent, when we use these functions, we always have an input, all right? The input is always the part that we write inside of these parentheses here. If you're back in your algebra classes, then we might call this the domain. This is the set of numbers that you're actually allowed to put into a function, all right? So the domains of these functions are all angles. We're only allowed to ever put angle stuff in our calculator. That is crazy, crazy important, all right? So angles only. Never put a side into one of these functions, all right? The sides are all on this side of my equation, all right? And you're going to notice, this is related to that last video, that we're talking about opposite sides and adjacent sides. So these are sides of the triangle. And they're sides of the triangle as they relate to the angle that's in our equation here. So we'll say the input angle. So what we do is we look at the angle that we want to use for this function. And then we decide what sides are opposite, what sides are adjacent to that angle, and then what side is the hypotenuse of our triangle. And then depending on what sides we have, we can pick sine, cosine, or tangent to either help us solve for one of the missing sides or help us solve for the angle itself. So the whole SOHCAHTOA thing, where does it come from? Well, sine is an opposite side to our angle divided by the hypotenuse. So an easy way to remember it is sine is opposite hypotenuse. Opposite over hypotenuse. That's so. Cosine is adjacent over hypotenuse, so we say ka. And then tangent is opposite over adjacent. Toa. Put them all together and you get SOHCAHTOA. All right? And those are the tricks. Those are the functions themselves. But to see how they work, we have to really start looking at some examples for these things. All right? So on each one of these examples, we're going to want to draw our triangle. All right? And then based on what it is that's unknown, we're going to want to see what's our angle, what side is opposite, what sides are adjacent, and what sides are hypotenuse. And then we'll see how we can solve for the missing side or angle. We're going to start, all right, by solving for some sides. These are a little bit simpler, and then we'll talk about solving for angles because then we have to do some funky stuff with functions. It's a little bit weird, but we're going to use our calculators to kind of help us out here. All right, you're going to notice I brought out my calculator to kind of help us out. So we're looking at our calculators to help us while we solve some of these problems. I have my virtual TI here, all right? And on my virtual TI, we're going to notice that we have three buttons, sine, cosine, and tangent. Your calculator has to have these three for us to be able to do sine, cosine, and tangent. So it's all programmed into a calculator to give us values when we do things like take a sine, cosine, or tangent of a number, specifically angles, all right? So these are our first three examples. We're going to work our way through them. I'm going to have to move my calculator around, but I want you to see how these things go in so that we can actually solve them, all right? So our first example here, we're given an unknown side B, then C is our hypotenuse, B, our angle B is 56 degrees. One of the first things we want to check on our calculator is to make sure that we're in the correct mode, all right? I'm trying to turn my calculator on here. Alright, look, apparently I was plotting in my calculator. Alright, so we're going to start here with my calculator, and on my TI, I'm going to hit the mode button. And there's a couple things that I want to check. Alright, specifically, I have to be in degree mode. Alright, so I went to the mode button. Alright, I hit mode, and notice that right now radian is selected. So I'm going to change that to degree, otherwise it's not going to do my calculations correct. Okay? I'm going to go back to my screen here. Now my calculator is all set up in the correct way so that I can do these calculations. Every time you come into class, you're going to have to make sure that you do that. Alright? Every time. Alright, I'm just going to quickly create a little scratch pad for us here. So we're going to do this first example. We're going to start by drawing a picture. Alright? My picture will be my right triangle. I have sides A, B, and C. I have angle B, and I have angle A. Alright? Now I want to write my givens. Right now I am given side C, which is my hypotenuse, and angle B, which is 56 degrees. Alright, so side C, which is my hypotenuse, and 56 degrees for my angle B. My unknown in this problem, alright, is side C, or side B. So for this problem, I'm actually going to ignore angle A, and I'm going to ignore side A. Every one of my equations has three variables in it. One angle and two sides. Alright? And we're going to notice that we have one angle, right? One side, and we have one unknown side. And so we're going to use that to help us out and solve with either sine, cosine, or tangent. Alright? So how do we pick? Well, the first thing we do is look at our angle. Alright? This is angle B. Angle B is related to side C and B in the following ways. Alright? Side C is always the hypotenuse. So I'm going to want to make sure that I pick a function, sine, cosine, or tangent, that has hypotenuse in it somewhere. Alright? Side B, alright, if we look at our angle B, side B is opposite angle B. So what I'm looking for is a function, sine, cosine, or tangent, that has opposite and a hypotenuse. So I'm going to go back and I'm going to look at my three equations, and I discover that sine, alright, is opposite over hypotenuse. So that's the one that I'm going to use. I know that because that's what I discovered in my picture up here. So sine of theta is opposite over the hypotenuse. So I always look at my angle and I look at how my sides are related to it. Now I'm going to change this equation a little bit so that it matches the variables that we're using in this problem. So theta is always an angle, right? So it's always an angle. In this case, we're talking about angle B. So I'm going to say sine of angle B, right, is equal to my opposite side over my hypotenuse. In my picture, side B is my opposite side to angle B, and side C is my hypotenuse. So this is the equation that I would actually substitute into. So sine of angle B is equal to side B divided by side C. Now I'm going to substitute my values. So sine of my angle B, and remember we only ever put angles into this function. Alright, this is my input. 56 degrees is my input to my function sine. Side B is my unknown, so I'm going to leave it in my equation, and side C is 7, just like that. And now all I have to do is solve for side B. To do that, I'm going to multiply by 7 on both sides. The 7's on the right side cancel out, because we have 1 in the numerator, 1 in the denominator. And we're left with 7 times the sine of 56 degrees on the left side. That's equal to B. So how do we put that into our calculator? Well, Sine of 56 degrees, when I do it as an input, it's going to give me an output. That's the range of my function, right? So if I do my input, all right, I can do 7 times, and here's how I use it. I hit the sine button, and we see that it starts the parentheses. This is where I want to put my degrees, 56 degrees. And when I do this, it's actually going to give me a number answer. In this case, it says that side B is 5.80. So sine of 56 degrees is a number. There's an output that goes along with it. It's part of the range. And when I take 7 and multiply it by that value, I get 5.8. And that's how I use sine. And the other functions are really, really similar to this. But we could be solving for side B, side C, all right? And we could also eventually solve for the angles as well. We'll do that in the next video. So I'm going to clear this. We're going to do the next example a little bit faster. All right. I'll go ahead and clear my calculator. Here I have side B. I'm going to look for side C, which is my hypotenuse, and I'm going to be given angle A, which is 35 degrees. All right. So I have my triangle, maybe a little bit bigger. Side A, side B, side C, angle B, angle A, right? Side B is 12, angle A is 35. So this is 12, angle A is 35 degrees. I want to look for my unknown side, which is my hypotenuse, side C. So this is my unknown side. So what I'm going to do is, I'm going to ignore angle B, I'm going to ignore side A again. And I'm just going to look at these sides and this angle. So related to angle A, which is 35 degrees, side B is right next to it, so side B is adjacent. Side C is always the hypotenuse. All right. Angle A is my reference angle, as I would call it. So if I look at my equations here, cosine uses adjacent and hypotenuse, so I'm going to choose cosine to solve this. And you can't just pick any function that you want. You have to use the one that matches your givens and your unknowns. So cosine of theta is adjacent over hypotenuse. That's the ka. All right. The angle that we're using here is angle A, so I'm going to replace my theta. That's this thing right here. That's theta. All right. With angle A, and then I'm going to replace my adjacent side, which is B, and my hypotenuse side, which is C. Now I can substitute right into this equation. Cosine of my angle, which is 35 degrees, that's angle A, is equal to side B, which is 12, divided by side C, which is my unknown. Now we have our variable on the bottom. This is a place where a lot of people make mistakes, so let's do this right. If C is on the bottom, I'm going to multiply it out, right? C's are going to cancel on the right side. On the left side, I'm going to get side C times the cosine of 35 degrees is going to be equal to 12. Then I'm going to divide both sides by the cosine of 35 degrees. And so this is a little bit wild, all right? But cosine of 35 degrees is actually a number. It's a value. We're going to punch it into our calculator, all right? And you could do that now and then divide both sides by it, but one of the things about cosine is that it's a fraction and it has a lot of decimals, and you want to keep as many as you can. On the left side, cosine of 35 over cosine of 35 ends up canceling out. On the right side, we have 12 divided by the cosine of 35, and that's going to give us our answer for side C. So how do I punch it in? I do 12 divided by cosine 35 degrees, all right, and I hit enter, And there we go. In this case, side C is 14.65. Let's look at one final example, and then we'll move on. All right. Side A is 4, B is our unknown, side B is 70. You could probably guess what function we're going to use on this. All right, angle B, angle A. You have to draw this every time because we want to determine what things are opposite and what things are adjacent. So A is 4, angle B is 70, all right? And we're going to be looking for side B, that's our unknown. So I'm going to ignore angle A and I'm going to ignore side C in this one because they're not my givens or my unknowns. All right, I'm looking for side B. So side B is opposite angle B, so I have an opposite side. Side A here is right next to angle B. It helps make it, so this is adjacent. So I'm looking for a function that uses opposite and adjacent. That's tangent. So tangent of theta is going to be equal to the opposite side over the adjacent side. The values that I'm going to use, we're talking about angle B. So this is going to be the tangent of angle B is equal to the opposite side. In this case, side B is opposite angle B. Side A is adjacent. So we have tangent of B is equal to side B over A. I have the tangent of my angle, 70 degrees, equals my unknown side B over my 4 right here. I can go ahead and solve that by multiplying by 4 on both sides. All right. So all I have to do is 4 tangent 70, and I get 10.99. So those are examples of solving for sides. So far we haven't had an unknown angle, and that's what we're going to do in the next video. But here are 3 examples of solving for sides, opposite, adjacent, and hypotenuse using sine, cosine, and tangent. You can really use any combination of those things, all right? You're just looking for your givens and your unknowns, picking the correct function, and then substituting and solving.